third type of salt which is obtained from weak acid and strong base. The last one, copper sulfate, which is obtained from strong acid and weak base. Now here we will discuss the third type of salt which is obtained from weak acid and strong base, such as sodium acetate, CH3COONA, aqueous. Now sodium acetate, CH3CONA is obtained from which strong base and which strong acid? It is obtained from weak acid such as acetic acid, CH3COOH. So this one obtained from weak acid such as acetic acid, CH3COOH. And which strong base? Which one is a strong base? Sodium hydroxide, NaOH. Sodium hydroxide, NaOH. So weak acid such as acetic acid, CH3COH, and strong base such as NaOH. So this is the salt which is obtained from weak acid, acetic acid, and strong base NaOH. So this anion part, CH3CO minus from a weak acid and the cation part from the base, which means the anion part CH3CO minus from acid and the cation part such as Na plus, which is from base. So this is the salt CH3CONA, which is a strong electrolyte. So we know that in aqueous medium it dissociates almost completely. So it is a strong electrolyte. When it dissociates in water, it dissociates almost completely in aqueous medium. So that will give us CH3CO minus, aqueous, plus Na plus. So aqueous solution of CH3CONA sodium acetate give us ions, anion CH3CO minus, acetate ion, and sodium ion Na plus. Now we know that Na plus is a part of strong base. So that is why Na plus have no tendency to react with water. We know that any part of strong one, either strong acid or strong base, it does not take part in hydrolysis. So Na plus is a part of strong base NaOH. So that is why Na plus does not react with water, have no tendency to react with water, means no hydrolysis in case of Na plus. But the CH3CO minus is a part of weak one, such as weak acid. That is why CH3CO minus acetate and can take part in hydrolysis, means they react with water. So I will write the reaction between water and CH3CO minus. CH3CO minus aqueous, CH3CO minus aqueous, it react with water, liquid, equilibrium established. Then it form, we know that it form again weak acid, CH3COH, CH3COOH, aqueous, plus remaining what is the remaining factor? OH minus, aqueous. So we have OH minus ion, which means the aqueous solution of sodium acetate contain excess of OH minus ion. That is why we can say that the aqueous solution of sodium acetate is what? Aqueous solution of sodium acetate is a basic one, because it forms OH minus, and we have already discussed the plus sign means acidic and minus sign means acidic. In the last part, in case of copper sulfate, CuSO4, aqueous solution of copper sulfate is one acidic one. Why it is acidic? Because that time that copper sulfate contain excess of H plus ion or excess of H3O plus ion. But here it is a different one. Here aqueous solution of sodium acetate contain OH minus, excess of OH minus 1. That is why we can say that the aqueous solution of CH3CONA sodium acetate is basic one. So this is basic one because it contains basic substance that is excess of OH minus N, and we know the strength of basic solution. Basic solution turns red litmus paper blue, acidic one blue to red, and basic one red to blue. So in that case, the aqueous solution of CH3CONA means a basic solution, it turns red litmus blue. Why it turns red litmus blue? Because it is basic. Why it is basic? Because it contains excess of OH minus ion. So we have the last type of salt, the salt which is obtained from weak acid and weak base. So that was the last part, last salt, the obtained from weak acid and weak base. We have a number of examples of salt that obtained from weak acid and weak base, such as ammonium fluoride, ammonium cyanide, and ammonium acetate. Now the salt of the salt which is obtained from weak acid and weak base is either acidic or basic or neutral one. It depends on the relative strength of weak acid and weak base formed in the hydrolysis. So the salt which is obtained from weak acid and weak bases may be either acidic, basic, or neutral. It depends upon the relative strength of weak acid and weak base formed in the hydrolysis. So we have three examples, and we will explain this example one by one. So let us find out the explanation for first example, ammonium fluoride. So here we will find out whether it is acidic, basic, or neutral. So let's begin with first example, ammonium fluoride. So ammonium fluoride is a salt of weak acid and weak base. Weak acid such as HF and weak base such as NH4OH, ammonium hydroxide. So it is a salt which obtained from weak acid such as hydrofluoric acid HF and weak base such as ammonium hydroxide NH4OH. So F minus is a part of acid and NH4 plus is a part of base. So combination of weak acid and weak base to form salt ammonium fluoride. Now we know that the aqueous solution of NH4F is a strong electrolyte, so it dissociates almost completely. So NH4F aqueous solution, it dissociates almost completely in aqueous medium. That gives us ions cation NH4 plus MnF minus aqueous medium. Now we know that these two ions are the part of weak one, means NH4 plus and F minus are the parts of weak acid and weak base. F minus is a part of weak acid and NH4 plus is a part of weak base, which means both ions can take part in hydrolysis. They have tendency to react with water. Only the part of stronger one, whether it is stronger acid or strong base, do not take part in hydrolysis. They have no tendency to react with water in case of only part of strong acid or strong base. But in case of a part of weak acid or weak base or weak one, that ions can take part in hydrolysis. They can react with the ions of water. So both ions NH4 plus and F minus can react with water. So here I will write reaction of both with water one by one. So NH4 plus aqueous, it react with 2 times water, liquid, equilibrium established to form weak base such as NH4OH plus acid one, which acidic substance or which acid, H3O plus ions. So H3O plus ions, aqueous. This H3O plus indicates what? This H3O plus indicates the substance is acidic one. So now we will write the second reaction related to F minus. F minus also react with water, aqueous plus H2O reversible to form weak acids such as HF plus OH minus, aqueous liquid. Now OH minus indicates what? OH minus indicates solution is a basic one. So we have two ions. Aqueous solution of ammonium fluoride contain two ions, H3O plus ion, also OH minus ion. Now the question arises whether the NH4F is acidic or basic one. So when we compare NH4 plus and F minus in terms of hydrolysis, NH4 plus ion undergoes hydrolysis more as compared to F minus, which means in the other words the hydrolysis of NH4 plus ion is slightly greater extent as compared to the F minus. As a result, the ions, H3O plus ions formed in the aqueous solutions are more as compared to the OH minus ion, because the hydrolysis of NH4 plus is to greater extent as compared to F minus. So because NH4 plus undergoes hydrolysis more as compared to F minus, it forms more H3O plus ions as compared to OH minus. So which means the H3O plus ions formation is greater as compared to OH minus ions, which means the aqueous solution of NH4F ammonium fluoride contain H3O plus ion, more H3O plus ion as compared to OH minus. The number of H3O plus ion is more as compared to OH minus ion. That indicate the aqueous solution of ammonium fluoride is acidic one. So that indicate acidic one, because the ammonium fluoride contain more hydrolysis of NH4 ion. That is why more ions of H3O plus is formed in the aqueous solution as compared to OH minus ion. And we know that plus means acidic, so more excess H3O plus as compared to OH minus ion. That is why ammonium fluoride aqueous solution is acidic one. And we know the strength of acidic one, it turns blue litmus red. So acidic one, because it is acidic, it turns blue litmus red. So ammonium fluoride aqueous solution, it is acidic one. This one is acidic. So we will find out here the salt of weak acid and weak base such as ammonium fluoride is acidic one, because it contains excess of H3O plus ion as compared to the OH minus ion, and because it is acidic, it turns blue litmus red. So in that case, in case of NH4F, Ka is greater than Ka. I will write here Ka is greater than Kb. I will round up here. In case of ammonium fluoride, Ka greater than Kb. Second examples of salt which is obtained from weak acid and weak base such as ammonium cyanide. Last one, the salt obtained from weak acid and weak base, that was ammonium fluoride, which is acidic one. Now here we have to find out NH4Cl is acidic, basic or neutral one. So let's find out the salt obtained from weak acid and weak base. Second example, ammonium cyanide. Now ammonium cyanide is obtained from weak acid such as ammonium hydroxide, NH4OH, weak acid, HCN, hydrogen cyanide, and weak base NH4OH. So Cn minus anion part from acid and NH4 plus cation part from the base. So it is a salt which is obtained from weak acids such as SCN and NH4OH. Now NH4CN in aqueous medium it dissociate almost completely. Aqueous it dissociate almost completely. That gives us ions NH4 plus aqueous plus Cn minus aqueous. Now we know that both part NH4 plus and Cn minus are the part of weak acid and weak base. That is why both ions can take part in hydrolysis, means they react with water. So here I will write the reactions of these ions with water one by one. NH4 plus ion aqueous react with 2 times water liquid to form weak base NH4OH plus acidic one H3O plus ions H3O plus ions aqueous. Now we will write this reaction between second ion in water Cn minus aqueous react with water H2O, reversible equilibrium established to form HCN plus OH minus aqueous, which means the aqueous solution of NH4CN contain H3O plus ion, also OH minus ion. In the last case NH4F, we have seen the H plus ion, means H3O plus ion, are more as compared to the OH minus ion, because the hydrolysis of NH4 plus is greater than F minus ion. That is why the ammonium fluoride is acidic one. But here the condition is, here the case is different one. Here the OH minus ions are more as compared to the H3O plus ions. Why? Because here the Cn minus ion undergoes hydrolysis to a greater extent as compared to the NH4 plus. So because Cn minus ion undergoes hydrolysis more extent, greater extent, slightly greater extent as compared to the NH4 ion, that is why, because it undergoes hydrolysis more, it forms more number of OH minus ion as compared to the H3O plus. So in that case the OH minus ion formation is greater as compared to the H3O plus. And because OH minus ions are more excess in aqueous solution of ammonium cyanide as compared to the H3O plus, NH4CN is a basic one. So it's a basic solution. It is a basic one. So NH4CN aqueous solution of ammonium cyanide is basic one. Aqueous solution of ammonium fluoride is acidic one. Aqueous solution of ammonium cyanide is basic one because it contains more OH minus ion as compared to the H3O plus. Means here Kb greater than Ka. Last time Ka is greater than Kb because it is an acidic one. Here Kb is greater than K. That means the solution is a basic one, and we know the strength of basic solution. It turns blue, red litmus blue. So here it turns red litmus blue. Now we will explain the last example of salt which is obtained from weak acid and weak base such as ammonium acetate, CH3COONH4. Now CH3CONH4, it is obtained from weak acid and weak base. So here we have to find out this salt is whether it is acidic one, basic one, or neutral one. So CH3CONH4, it is obtained from weak acid such as acetic acid, CH3COOH, and weak base weak acid such as CH3COH, acetic acid, and weak base such as ammonium hydroxide, NH4OH. So this part NN part is from acid 1 and cation part NH4 plus cation part from the base. So now we will see the dissociation of CH3CONH4 in aqueous medium. It dissociate almost completely in water, so that gives us anion CH3CO minus plus cation NH4 plus aqueous. Now we know that both part cation and anion are the part of weak acid and weak base, so they take part in hydrolysis. They can react with water. So I will write reaction of both ion with water one by one. CH3CO minus plus H2O aqueous liquid reversible to form weak acid CH3COH plus base OH minus aqueous. Then second reaction NH4 plus react with 2 times water, aqueous liquid reversible to form a weak base NH4OH, aqueous plus ions H3O plus aqueous, which means the CH3CONH4 aqueous solution of ammonium acetate contain both OH minus and H3O plus. Now here in this example, in case of CH3CONH4 ammonium acetate, the relative strength of acid and base is same, means K is equal to Kb. So in that example, Ka is equal to Kb. What that means? Which means the number of ions OH minus is equal to the number of OH minus. Means there is a equality maintained between OH minus and H3O plus ion. Or we can say that the reaction produce OH minus ion equal to the reaction produce ions such as H3O plus. Means the number of OH minus ions is equal to the number of H3O plus. So here OH minus ions is equal to the H3O plus ions, means there is equality maintained in case of OH minus and H3O plus. In the last example, ammonium acetate, which means K is equal to Kb, which means the solution is which one? Solution is what? Solution is neutral one. So here the solution is neutral. Why it is neutral? Because K is equal to Kb, because the number of OH minus ion is equal to the number of H3O plus ion. In the last example, in the first example that we have explained, ammonium fluoride is acidic one because it contains excess of H3O plus as compared to OH minus. Then next example, ammonium cyanide, NH4CN, which is a basic one because it contains excess of OH minus and then H3O plus. But in the last example, in case of ammonium acetate, the number of OH minus and number of H3O plus is same. That is why K is equal to Kb. That is why we can say that the solution is a neutral one.